Hello everyone, welcome back to our Lee County Library Science Club. It's great to have you with us once again. I just want to remind you, please make sure you have your parents' permission and some supervision when you're working on these experiments with us. This week, we are actually going to move this match with nothing but electricity. We're not going to touch it, pull it, anything. First, we know that electricity is the movement of electrons between molecules, right? So you have a nice long chain of molecules or atoms, and the electrons travel along that chain, and that's what gives us the movement of electricity, gives us the power. But there's another kind of electricity which we call static electricity. Now, static electricity is an imbalance of electrons within a material. And this creates a charge on that material with the potential for electrical movement, but there's not actually active electricity traveling within that material yet. What causes static electricity? Well, certain materials, like the rubber in this balloon, they may not have a really strong bond or strong hold on the electrons within those molecules. So, if you take some rubber and you rub it across a somewhat abrasive material like your shirt or maybe the rug, something like that, you can actually knock the electrons off of this rubber material. And if you move those electrons off, what happens? Well, now there's more protons than electrons within this balloon, right? And it has a charge. But if this has a charge and we bring it close to something that hasn't had a charge on it yet, it can actually create a charge within the other material, right? Because it can push the negative away and attract the positive end of a molecule, and it can create that charge, and they can pull against each other. Now, if you get them close enough and there's a strong enough pull, you've all experienced what happens next, right? You actually get a spark that jumps across those two materials. You've probably had that happen, right? You accidentally touch something and it shocks you. That's the static electricity that you have built up, or maybe the object had built up. And you get close enough, the electrons seek to fix that imbalance. And so they jump from one material to the other, and you have a static shock. But if the objects don't get close enough, or there is some kind of barrier between them, instead of the electrons jumping, well, we still have an imbalanced charge, right? So those charges will pull against each other. And that's what's actually going to happen here. We're going to create a charge in this balloon, and when we bring it close to the match, it's going to pull on it. However, this charge is not a very strong force. Okay, if I do it right now, build up a nice charge, and I bring it close to the match, well, it's not doing anything, is it? The match is just sitting there. And that's because the pull from this balloon is not actually very strong. Now, it's interesting, when I rub my hand across the balloon, I can actually hear the static moving, right? I can hear the electrons jumping in tiny little sparks. Pretty cool. But, as we said, the match didn't move that time, did it? Well, as you can see, this match has basically one long edge that was sitting against the table. And that edge has relatively a lot of surface area for this match. And as we know, surface area creates friction. So there's too much friction between the match and the table for the balloon to actually be able to move it. So we're going to have to do something first to reduce the friction on this match so that the force from the balloon can be strong enough to move it. What we're going to need this week is obviously a balloon, a match, we need 2 nickels. Okay, this is what we're going to use to reduce our surface area. And then we just need a plastic cup. You definitely want a clear one so that you can see what's going on inside. Alright, let's get started. So the first thing we're going to do, you want to put 1 nickel on the table with the face down so that you see the building looking up at you. You're going to take your other nickel, lay it on its edge on top of the building very gently, so we have 1 nickel standing up. Okay, that's the goal here. The next thing we're going to do, very gently hold your match in your hands and lightly lay it down on top of the nickel. There. So now, as we said before, there's a lot less surface area between the match and the nickel, right? So that means there's also a lot less friction. So hopefully we've reduced the friction enough that we'll be able to move the match with the balloon. Alright, next thing we're going to do, we're going to take our cup and put it over the match. And this is to create a little bit of an insulator between the match and the balloon for 2 reasons. One, so that just in case no spark will jump, but also so that the force from the balloon won't just knock the match off the nickel. Okay? The plastic can hold a little bit of charge as well, and it'll help balance the charge from the balloon and keep that match balanced on the nickel. Now that being said, when you try to put your cup over the match, it's possible the plastic already has some charge in it. So move slowly, okay? And if it has too much charge and knocks your match off, you can actually put some water in it. The water will help get rid of some of that charge. Alright, so we've got it set up. We've got the nickels with the match balanced on top and our plastic cup surrounding it. Next, if you haven't already, blow up your balloon, get it nice and big, and then you need to give it a static charge. You can rub it on your clothes, rub it on your hair, rub it on the carpet, okay? Somewhere that you'll create some friction between the 2 materials and allow the electrons to be knocked off the balloon. Now, once you have that charge, go ahead and bring your balloon slowly in close to the match. You want to go slowly so you don't just knock the match off the nickel. Once you get it close enough that it starts to move, don't keep moving closer to it or you'll knock it off. But instead, you can move it around the cup. You can get it to spin. Now, static electricity is something we see in our everyday lives, right? You can walk across your carpet in your socks, and then you go grab your doorknob or door handle, and suddenly you shock yourself. And if it's so prevalent at home, just in normal circumstances, well, it can be pretty prevalent in other more dangerous areas too. So the potential for static electricity and mitigating static shock is a really important consideration in a lot of industrial settings, manufacturing settings, chemical settings. Okay, there's a lot of areas where a sudden electrical transfer or a spark could really cause a lot of damage. So being aware of static electricity, knowing what causes it, what allows it to move, and how to prevent it are pretty important. Thank you so much for joining us today. We're excited to see you next time. Bye!